Hello, my name is Andrejs, and first, since I constantly receive a feedback that my sense of humor is very specific, all my jokes, not reflecting the Printify stand or point of view, they are only mine. And we love Snowflake very much. So first of all, a little bit about Printify. What we are doing, we are helping people to become merchants and sell their merch. How? We have a big database of a product, starting from a t-shirt, ending with the pen and Max. Then you create your awesome design with ChatGPT, and you start selling through the platforms that are mentioned there. And now we have a very amazing feature from my point of view. You can open your own website using our engine. Like click, and you have your website, myamazingproducts.printify.me, and you can start selling. Payments is covered. You don't need to think about anything except this design and receive payment. Some numbers we are founded, looks like somewhere near Snowflake in 2015. We have 600 employees now. As I said, almost 1,000 products in catalog, 100 printing locations, international investor, and we also Forbes listed. Not only Snowflake is Forbes listed. And these things are our employees' core values. Basically, what is interesting for me as an engineer is that we don't know anything, we learn it all. And it basically was our long 3 years journey with Snowflake, when we almost have zero knowledge of a Snowflake. Me personally, even zero knowledge in SQL. Only during work with Snowflake, I knew what is inner join and left join, how it differs. And a little bit about me. Yes, I'm Andrejs. And since if you have kids who love playing games, I'm still playing games. And if you're, yes, if these four your kid playing, maybe he will become a data architect or she. During the COVID, I started triathlon and made my first half Ironman distance last year. Also, my colleague said that I need to mention that I'm a challenger winner on Printify. Challenger means basically I'm bullying everybody in Printify. On each their decision, I have my own opinion and I'm going against the flow, let's say. And this is my motto: everything is possible. Impossible things just requires more resources. So why Snowflake, you won't ask me, and there is only one reason: because Snowflake out of the box supports JSON formats. And since all our production database those times were MongoDB with the JSON, what is the simplest way to start analyze it? Ingest it in the warehouse, which supports JSON out of the format. We can also say that we wanted a fancy and top-notch, and the year we chose Snowflake, it was become a popular, so we made the stake that it will become better, it will provide more features, comparing with, for example, Databricks, who already raised their peak with Spark, for example. Basically, since Spark, nothing released by them. Sorry, that's Databricks, nothing personal. And another good thing that for us, there was no migration. We were building the warehouse from scratch, so only right decisions from a start, which was amazing plus. Little bit numbers where we are now. We have 60 terabytes in Snowflake across all databases. We currently use only 7 warehouses. The sizes are from XS to L. XS are mainly used for ETL. Only one pipeline uses L, but the table is huge. And why L? As already was mentioned, we used also XS there, but it was running for 3 hours, and guy said, okay, you can optimize, just use L, same cost, but faster. Now it's 1 hour and done. Yes, basically ELT, and we have now dedicated warehouse for BI, because we now made a cool feature for a merchant where merchant can go and analyze their sales, their insights, using the Looker. So we have embedded Looker in our web page, which works then with Snowflake, and it works with prepared tables and stuff like that, which is also a cool feature. And we also now use Snowflake for various business microservices to receive some quick information about user, merchant, or I don't know, products. And currently we have 100 monthly active users in Printify. So now features that we love and use in Snowflake more than others. Alphabetical order, not in priority. First one is the cool build SQL functions, and what I personally love, custom UDFs. Custom UDF is basically the code when you write Python or Java. Unfortunately, we'll still use Java and JavaScript, where you basically define the input, output, and then you natively use it from a Snowflake, like select your custom UDF, column and name, and everything is processed. Python was very critical since we have a payment system integrated, and they are so paranoid that even to us, through all secure channels, they still share the encrypted data. You need to decrypt it. And the only libraries that we can use for decryption is written in Python. So this is why this is the most critical Python UDF that decrypts and store everything in a safe location in a special table. Dynamic masking policies, a brand new feature for us since we built all 3 layers. Now we are using dynamic masking policies to hide all personal and sensitive information, but still make an analysis available. So basically, customer ID is hashed. Analytics can analyze, but cannot get information who is this customer. So if even analytics will decide to run away from us, he will not know our user base. It's a very important thing. Another one that saved my job multiple times is the time machine, the backups. When you know, thinking about summer and already playing season, you accidentally write drop table, and then oops, this time machine saves you. Pre-built ML models, not so wide, but I use it when I need to show to the upper management, our gods, some quick insights. I can predict some things, for example, growth of a database, and say, okay, we need to do something. We need some retention policies because machine predicts it will be twice bigger than next year. And especially with the combination with the pre-built charts, it's make, 5 minutes and you have a report to SLT ready. And then you charge 8 hours for. Yes, Snowpipe, Snow streaming is our main ingestion pipeline, and streams we use to detect changes between layers. Also, there is amazing non-functional features, and the most important, I would say, and the best for now is the amazing support. It's really amazing, and as you might see, all titles in Snowflake, there are sales engineer, marketing engineer, and they also have support engineers. That actually is true because you are not chatting with the guys who advise you switch on, switch off, switch off, switch on. It's already an engineer who understands your problem and it helps you at once. I will speak in details further. Yeah, built-in visualization, integration with S3, also now very popular for us. Query history and transparent costs. The combination of these two, I would say, is very critical because you at once with the query history can analyze which query is taking the longest and you can optimize them, how much it costs, or just deduct from a salary all these costs. Snowflake data sharing or marketplace, I don't know, guys, how is this feature called correctly, but basically it's when another company with which we are working shares their data about us. Snowflake UI, of course, used by data scientists and data analytics, and SSO, also very cool features that protect us from unauthorized access. So this is what we built in 3 months. Our first architecture overview. The main base was Mongo with the JSONs, a little bit of Postgre, and a little bit of MySQL. And also some custom insertion through various API, which is run on our Kubernetes clusters and just directly inside through Kafka, and direct integration with S3. Why Kafka, you want to ask? Because I like Kafka. I think the best queue ever. Kafka has a native connectors with all this, and the most important with this one. So basically no configuration was required. I just downloaded an example, changed the database name, and start work. Here is an Airflow, which is our orchestrator. Not so proud of the choice, but we need something to orchestrate, and we extract all metrics, telemetry, metadata to Prometheus. We built Grafana to track what is happening, and if something happening wrong, we receive alerts. In Prometheus, that is basically connected to OpsGenie, if you know such tool, that can enable your phone even from mute mode, call you and say you have a problem, please wake up. This is how we assure basically being live 24/7. And for BI, we use Looker, also we extract data to microservices, and our main stack is AWS, and tooling is written in Scala and Python. To be honest, in Scala only one tool, because I love Scala. And by the way, guys, Scala is enough. Java you can remove, it's not a real language. So what we built? We built so-called thingy as a lakehouse. Why lakehouse? Because we use data lake 3-layer approach. But why warehouse? Because we have only databases and tables. I don't count that you can keep everything in S3, and it's seamlessly integrated with Snowflake, but I still think it's fake integration. I want to copy everything inside. So we use databases as layer. So basically we have database control, clean business. Also we have temporary and libraries, and also environments. Same thingy, database prod, preview, and test. So here, low row layer. So what we have initially, we had a task that our production database was 3 terabytes. It's not big in scope of big data, but it's big for MongoDB. And especially when you're trying copy live production database to Snowflake. It took too much sleepless nights, but the problem was mainly on the MongoDB side, because they don't support any multiple like parallelization when you're copying. It's only one thread that connects to Mongo and start to copy, and copy 3 terabytes was unrealistic, so we logically divided and copied collection by collection, and for the collections that were too big, we started 10 processes, which took these document IDs, another one this document IDs, and this is how we parallelized. Everything was done with Snowpipe. I think it's Snowpipe streaming first version. Then we migrated to Snowpipe streaming when it started live, and this V1, 2, V3 means that we also did multiple mistakes during this thing. First, we started to copy full documents. Not the delta, but only receiving full documents. So if you change one field in the big document, I receive full document. Of course, we start to see the performance degradation. The costs were a little bit higher. Then we decide, we can just make a CDC, change data capture, on the change of the document, and then in Snowflake we can combine it. And we did it. And everything worked perfectly, cost low, data there, everybody happy. But after 1 year, someone came and said, okay, I think we need to build a history to see how everything is changing. And we went back to the full documents and combination of the change data capture, so we are rebuilding it. If we need build next layers and understand what changed, first of all, we did initial load every time. Then one of us read the documentation, and we knew about the feature streams, which is very cool table that sits above on another table and track each changes. And it can work in 2 modes, I would say. It can track each change or only append. Of course, this part we did not read, and we use like full streams that track each changes. Despite the fact that we have only appends. And one feature of this stream, when it's not in append mode, only it works slower. And those time we use this UDF written in JavaScript to combine all change data captures to receive the latest version of the document. And we have one incident with this JavaScript, but it's about later. And then we rewrite it to the Python, because Python first is a little bit faster. And I see somebody doesn't agree that Python is faster. Yes, Python, from our perspective, Python is faster. And another thing that only one guy had a proficiency with the JavaScript. All others were Python guys. So in this code, Python was faster. What we did very cool, we started to write any kind of tools. And basically, I think this is the biggest advantage of Snowflake. Since the technology is so simple, basically, it's just a SQL executor, if we will abstract. It's a simple database with a SQL execution. You don't need Socratic knowledge to handle it. For example, for Airflow, you need a degree, and not in a computer science to manage it. For Snowflake, it's pretty easy. So since I don't like SQL, my guys don't like SQL, we thought, what we can do? Let's build the tools that will write SQL instead of us. And first, we created infrastructure tool. Since I was creating it, it was written in Scala language. And what it did, it basically creates a DDL that builds the infrastructure inside the raw layer. So basically, all create table statements, all create database, giving the necessary permissions to Kafka connectors. Also, it creates Kafka configurations and then deploy to the Kubernetes to start the connector and to start data flow. So all kind of things. And now, for example, we have automated process that we have after detection of new collections in MongoDB. Our auto detection bot says, there is a new table, do you want to import? If you answer basically yes, it creates new configuration. It uploads to Kafka, it creates new configuration in Snowflake, deploy everything, and data start to flow. So basically one click from engineer is now required, which is, I would say, very good. And if you think it's very hard to deliver or deploy or develop, no, because first thing we developed and deployed in 2 weeks, including proof of concept to see if the thing is working, all kind of dry runs and test runs, and the only bottleneck we had was MongoDB Kafka connections that we solved basically in 2 months. But the tool itself worked at once. And the most coolest thing, when you do all this automatic way, everything appeared in so-called clean layer, and data analysts started to work with it at once, because you can address JSON natively. And first data analyst and first data scientist started to provide insights just after the data was delivered. There's no need to, create fancy models, stuff like that, nothing blocking from them to work. Of course, if they are smart. And our data scientists and data analysts are smart. Those 2 girls that started, data scientist, it was Katya, is my favorite. It's the first data scientist who can deploy from zero to fully working model deployed into Kubernetes, write a Docker and stuff like that. It was first data scientist in my practice, because normally, data scientists, we won't do only models. It's your data engineering work to deploy it. And this is how our raw layer looks. Mongo, Kafka, infrastructure tools that control this and this, stream above the raw layer, which detects all changes and propagates them to clean. So this first pipeline is very simple. Just combine all data captures, receive a latest version of the document, and, of course, first support tickets. Basically, we had not too much. Now I think we have only 20. 70% would be we just need help. So people just explain us what we are doing wrong. And 30% were actually some malfunctioning. So first, we asked help with setting up Kafka and Snowpipe. The reason was pretty, I would say, easy. there was a mistake in documentation in our Snowflake website. There was a typo, I did everything correct, it was wrong, and then there was a communication with support agent, and he said, why you are doing this, you need to do this. I said, I'm doing this because of this. He said, okay, sir, you're wrong. He showed me the right way, they fixed the documentation this day, and that's it. Another one was help how to work with UDF JavaScript. There were some memory problems because it's not very explicitly to understand how much RAM basically you have in these XSS nodes. It was also explained to me. First I tried just cause the crash, segmentation fault. I was just requesting memory until it crashed. Then I say, okay, how much you have? But query optimization, of course, I think this I'm lacking. Still, maybe to be visible, in this profiler, you can open each query, and there is a profiler that shows you which step is taking how much resources and time. Then we have some resolution, 1-2 days before final resolution. First response you receive in an hour or two, and you receive, if it's something complex, you will receive a quick fix to avoid this problem, and the final solution will come in 1-2 days, like perfect solution. We have a couple of complex problems that we even do not still know what was the reason, but it's all fixed by Snowflake. We DDoSed the Snowpipe server. At some point, it started to decline and not lose, but it moved our messages to some secret storage. And the support at once showed us how to get it from there, and they said, yes, it's because you're DDoSing us. It's too much. But they fixed it. And a couple of hours. And these were high priority tickets. They were fixed in a couple of hours. One was investigated long, but as I said, quick fix was provided at once, so nothing critical happened. So clean layer. Here we started to develop more tools. And why? Because we had 100 of JSON collections that we need to normalize to tables. Of course, business wanted us to write SQL code. And I said, no go, guys. Because basically it's a monkey job. All collections plus minus have the same structure. We understand what to do. Just flatten it. Just make some simple analysis on types. And that's all. And this took to us 3 months to write the tool, which basically consists of profiler and generator. Profiles the JSON documents, understands its structure, data types, and generator basically generates a create table statement with appropriate type and insert into select statements. Very interesting thingy, because for 3 months on my reports to SLP members, I was saying it's in progress. They said, how much did you normalize? I said, no, currently nothing, but it's in progress. And they said, okay, maybe you need to start writing it by hands. I just said, okay, please, 1 more month. Give me 1 more month, everything will be good. And at some point, I think it was March, I came and they started to joke about that there is no tables, and said, no, there actually are. And they asked, how many? I said, all of them. And they said, normalized? I said, yes. How? I said, machine, it doesn't care, is it 100 documents or 1? If it can make 1, it can make 100 in no time. And then we encountered this thing is that we have 30 plus timestamp formats, and here we wrote another timestamp UDFs that try to understand which time format it is. And we reached this point when we did first delete from table were true and annihilated basically a whole layer. Also, I accidentally dropped the row layer, and the row layer, it's the critical one, and I said, okay, Andrei, time in Printify ends now. I started to Google a bit because I didn't know anything about int-ramble, and then I basically found the answer that you can restore simple as that select from at my favorite before, and then you just give a query ID that annihilated everything, and everything is restored. It was If you are curious, by the way, about pictures, I forgot to tell it, ChatGPT. So, only mistake I did, I admit it openly, I agreed to use this amazing tool Airflow, because normally I'm a tyrannic man. There is only two opinions, mine and incorrect. And since already I pushed for creating infrastructure tool, generator tool, profiler tool, I think there was some another tool, I said, okay guys, if Snowflake cannot write a UI for task, we can do it. Python, simple UI, let's go. They said, Andrei, please, we created 3 tools for you. Let us use something out of the box where everything is cool. And they said, okay, Andrei, we made an investigation, we select Airflow. Airflow is Python native, we have everything in Python, everything will work. They said, and everything worked until we had 5 pipelines there scheduled. And when we now have 230 pipelines, this stopped working each 4 months with like a segmentation fault on a database, unrecoverable. So you cannot, after migrate it to the newer version, you need to up another instance and perform physical migration. So we're still looking for a good approach. They still don't want to write our UI for Snowflake tasks. Maybe we will go to the self-hosted, not Amazon, but Airflow, just to recover it faster. Because on a managed instance, you cannot do much in Airflow. And after all these struggles were done, what we built? So basically, raw through the stream populated to clean. In clean layer, we use the profile tool to analyze incoming data, build the data model automatically. Generator tool generates the SQL queries, execute it on a Snowflake side, and we transform all data from NoSQL format to SQL format. All changes are tracked through the streams. So basically, streams are our core technology. And I want to complement here Snowflake a bit. First version of streams were they didn't like if the schema changed, but then it was fixed, and now you can even change schema and it's not corrupt the stream, if I'm right, and I think I'm right. And it was a game changer. And of course, SLT favorite and all hire manager favorite layer, business layer. And our motto there is testing in production. So as you know, we built the business layer with our generator tool itself. We use YAML format to configure everything, which is very cool because, first of all, YAML is very easy to generate from our profiler. And if, for example, data analytics see some shitty data model provided by profilers, they can go change this YAML and adjust the structures. And they commit it to GitHub, and automatic deployment, boom, and table is in a business layer in 5 minutes, let's say, or maybe 10. Very special thanks to our finance team, who were our first testers. Gvida, Jurgis, if you are watching these guys officially. Without you, it wouldn't be possible, because they were testing each change. So we deploy new model, new table, at once the feedback, guys, this wrong, this wrong, this wrong, this should be like that, like that, like that. Without them, I wouldn't think it would be possible to build it so cool. And another thingy I would like to take your attention here, that Snowflake is not used only by business and analytics and data science. That is missed from all the presentation. At first, our developers maybe were a little bit in ignorance state. They didn't create a Snowflake account. They debugged their code using the MongoDB. But you know, if you want to query something from Mongo, especially if you need some particular thingy, it's slow. And Snowflake can give you result already in a couple of seconds. Another good thing that we built inside the clean and the raw layer transactions. So we keep each change that was done on MongoDB. And if they know, for example, that incident was from 2 o'clock till 2:15, they can go in Snowflake and get all transactions that were made, find the faulty transaction, and basically debug their code. Business layer is much easier, still operated through amazing two-layer flow. Everything built on streams. And the only difference that in business layer we already, if row to clean was one table to one, like one JSON, one table. In business layer, it could be like 3 tables combined into one, no? So prepared data for analysis. Yeah, and as I said, generator tool also controlled by humans now. And of course, we developed fourth tool, QA, that basically generates queries that checks tables, are they compliant or not. No, like checking nulls, negative costs, no, basic check, and also reports to Prometheus, and then Prometheus sent in Slack a message, you have shitty data. Dynamic masking, basically also a game changer, because we started to invent bicycle. We started to think about some special tools, how we can protect data, and then we read the documentation. And we found that there is a dynamic masking, which is a pretty cool thing, because you define masking policy once, basically all rules, and then you simply on each column or table or how you want to organize, you apply a tag, for example, PI. And if the tag is applied, nobody can see what is inside except the hash. But when you create all your custom SH-based masking policies, don't forget about salt. This task was delegated to our, those days, junior developer who just created a SH function on the column and names. And then I just showed me how in 1 minute I can receive all information decoded. But I'm smart only because my bachelor thesis was about hashing functions. But yeah, also a game changer, and there is no even so big performance degradation, because first I did some... Yes, first I did very stupid thing. I created a view, and in this view, when I was selecting name and surname, I was applying this SH function, stuff like that, and it killed the performance. The masking policy, amazingly, but it works faster. I don't know why and how it's possible, but it do not require such computation powers that, for example, if you explicitly define a stage like through the view. Maybe because it's, I don't know, pre-calculates it somewhere. But amazing feature, top notch. And now about my favorite topic, money. Everything that is said is true. Money, first of all, costs are transparent. You see very detailed information about each warehouse. Now we also even went user. We are marking each query by specific tag. Is it ELT? Is it generated by the user? Is it, I don't know, some specific project related? And then by tag, we can calculate and say, okay, you release this project, use our warehouse, please, $100 to our... We did cost optimization. Yes, we did cost optimization twice based on this information. We reduced cost by 30%. And also when we mentioned that it is a kind of a priority for us, additionally in a year, Snowflake made an audit, said basically everything is good except, and then we received a list, which we did, and cost a little bit also dropped, but what improved dramatically is performance. So such case of support. And here is my favorite, is a total view of all tools we created. This you are already familiar. Quality assurance also generate. Also what we did more is a permission management. We also control permissions via code, also YAML, where you basically have a Snowflake user and all assigned roles. Then it generates a SQL query and execute it in a Snowflake. What is most cooler, this tool is attached to the databot in Slack. So basically you go in Slack and say, hello, databot, can you please grant me access to this table? Databot asks the correspondent person who is responsible for this data if he's willing to give access to this person. Then databot creates a PR here and permission granted. Query runner is another tool where basically data analysts can create their queries, give it to the query runner tool and say, okay, could you please launch it every day at 8? And it basically executes. Snow import, I hope you guys, you don't mind we use your branding, is basically snowimport.printify.com, only visible from our network, but there you can go and import all your Excels you want. You provide the structure, your Excel, and it's imported, or CSV. Also, it has integration, for example, with Google Sheets. You can give a link of a Google Sheet that will be imported to Snowflake. So now about future. No pressures. Yes, guys, I need one feature. What?
Yeah, I was trying to get it from. I know we are actually building the task framework that we want, but I didn't find the schedule yet but it is coming, but I tried to find it during today when.
What else would be cool? If some ERD diagram can be built out of the box, because currently we are searching for external tool, but you already may guess what is the result. We will be developing our tool that will build the ERD based on the commands, primary keys and stuff like that. Quality assurance out of the box would be cool. Coming?
It's already in private.
Oh, more integrations, I would say, would be cool, like with Google Sheets. And some out-of-the-box import, like Excel. What I mean here, like D&D, not Dungeons and Dragons, but like a drag and drop. Because Excel, you know, it's for management. It's I know you can do this put command, but it's too hard for them. If they can just go to Snowflake UI, drop the Excel, and so what we want to do and already exists, I would like to manage Snowflake through the Terraform. Recently, I again read the documentation, and I found that we can use Terraform at least for raw layer and infrastructure and for permissions. I think it's more convenient to use Terraform, not our YAMLs and SQL queries. More policies and quotas, like how much you can spend. And cost splitting based on query tags, just to see how much each department is spending, because if there is too much costs, it's always a data engineering problem somehow. With all this splitting based on query tags, I can show that we are not the bottleneck here.
I can give you a query that does it on a query level. It's in your favorite language, SQL, but you can actually modify it to work on query.
I think we already have it. We just need now to collect information and make reporting. We are now using this FinOut tool, which also has a seamless integration with Snowflake, so everything will be pushed there and everybody by names will be blamed and expelled. One last statement from me is I worked 7 years in enterprise, a long time, and I was always working on projects where there was a legacy thing, and I was only maintaining things. And I always had a dream, or question to myself, can I build a warehouse? Now I know that I can, but not without my team, and of course, everything that I told you is not done by me. I have Elvis, Roberts, Olga, Eriks, and Nikolai, our top leaders that help me. And another thing which may sound unrealistic, all newcomers deliver something useful into our warehouse in the first week of their working. There is no need to educate people because, as I said, basically Snowflake is a SQL executor. And if you have people who know Python, they already can work. And that's all. And don't use all these third-party tools. Go with your tools, because with Snowflake it can be done without all these unnecessary consulting firms. Thank you.